All right, on to a new project. Yep, I did buy a broken slot machine. The slot machine was a good deal. The guy actually had the original paperwork and they had the original receipt. Let's just say I got a great discount for what the guy paid back in 1988, like way cheaper. So it doesn't work. It lights up. And it lights up is all, fine and good, and the candle doesn't do anything right now. The lighting up is only half the battle. This is actually like a 1970 EM slot machine, so electrical mechanical. So inside there are no chips, there are no computer boards. Everything is just dials and wires and power going through them and switches that are switching on and off and rerouting power to different things based on a certain chain of events. Up on top here we have the coin counter. Like, this will light all over the cross here as you put more coins in and show you what you're playing, because you can play up to 5 coins, or if you're conservative, play 1 coin. And that control dials in there switches around every time. It like rotates like a clock every time it does, and it routes power to this, for example, this thing. It also routes power to the odds calculator, which is on this half the side of the thing, where it calculates odds and determining how soon somebody's going to win again. So when somebody says it's rigged, it's very calculated, but it's dials inside there to show it. It should say insert coin right now up here, and it's not. So it's indicating it's not ready to play a game. This would say coin accepted. This would say winner paid. You can see the wires dangling in the back there. That's got to tighten that up a little bit, but nothing too crazy. This does not light up. So I put a coin in. It actually falls out the bottom. So it's not registering anything. I'm going to open her up. Inside here, the coin comes in through here, and this is like the classic coin acceptor that mech that determines if the coin is an actual nickel or not, because you put a quarter in, it'll just kick it out. And it normally would kick it out down here. It would just kick it out here and fall through the bottom. That's where it gets rejected error. If this accepts it, then it comes out. It comes out here. It'll hit this switch, which is doing nothing, which is a problem. And this is normally energized and kicked in. So you see this little coil. This coil, you should have voltage going through it, and it's not, to keep this like tight like this. And that shoots it into the coin hopper, into those coins right there. And this is not happening. So what happens is it slides down here and falls out to like this spot, and then goes down this chute, which goes out the side. So if there's a real problem with it, someone's gonna put a coin in, it's gonna come right back out the bottom. They kind of put these on stands back then. I don't know what they would have done, but I have suspects on what's going wrong. This is like there's no power. So there's no power going to this thing or anything like that. Like, this thing should have power to it, and that's a problem. And I'm suspecting that we have a blown fuse in here. So I've got the multimeter here to check it out, and I'm gonna pull this hopper out. I'm gonna pause the tape and come back. I'm gonna pull this hopper out to see. The fuses are back there, so I'm going to see what they are, if the fuses are any good, and try to replace them. So, be right back. All right, I got the hopper out, and I can see the fuses back there. There's only 3 of them, and the one on the right I suspect is working, the 5 amp, because that would do the lights. The other ones are suspect. And I want to go back to this too, just explain why I turned the power off, so this is not going to happen, like it's unplugged. Why do I think this fuse is blown is because this mechanism should always be on no matter what. There's nothing else controlling this. There's no like switch or dial or anything that tells us to close except getting power. This is like basically hardwired into power to always stay shut. So when it turns off, it does this, like it just doesn't want to take any extra coins, basically, is what their design was. And this is kind of a diverter, is what I guess I would call it. And this coil is always supposed to be on when it's getting power. Like this should not be sticking out here. So, and it's wired, and I follow the wire. Well, I take that back. There is one reason why it could not be open, and that's if the coin hopper is full. So you look at the wires here, it's a gray with a yellow trim. Can you see that? Yeah, you can see it a little bit. Gray with a yellow trim. You can see it's kind of marked up. It's got yellow, trust me. And I follow the schematics, and it goes all the way down to this coin hopper, and you can see the gray with yellow trim. If I get a light on it, this is great television. Well, that's it right there. The gray with the yellow light right here. So this comes in to this switch, right? And if this is full, and this thing is up, you can kind of hear the click. Maybe not. There it is. So there, you can see the white thing going up underneath it. So this is pretty much doing its job, but it's closing it. So if anything, I'd be more suspect about not being open when it's getting full, but it's closing this. So this should be connecting the power through it and stuff like that. It's kind of a heavier duty switch, so it should be handling the voltage. And this is down, so there's definitely not too many coins in there. So it makes me suspect again about these. I just wanted to explain that this is pretty much always on. And the only time it's not on, and according to the schematics, is when this is up. And so that's definitely not up. The switch seems fine. I want to check these fuses. So let's check this one that I think is right. I'm going to back out of here a little bit. So this one is the 5 amp. It looks solid. You can see the metal in there. Looks like it's meant to take it very good, or take the. It's meant to take the voltage. And this is gonna be bad television here again, but you gotta connect the continuity across here. And you hear that beeping noise? That's a good noise. That means the electricity is able to go through it, which is great. So that means that fuse is fine. And I wanted to look a little closer. Just make sure it's the right voltage. It says 5 amp, 120 volt. Make sure. This is, I can't really tell. That says Ego. Maybe the other side might be better. 32 volt. It seems low. I don't see an amperage on here, so that's kind of concerning. It says that I don't. Well, it's working. I think that controls the lights. I think we're fine there. I want to probably check the volt thing because it says 32 volts and that might be a problem. All right, let's check this one. 50 amp, or I'm sorry, 50 volt, 50 amp. Oh, I think we found our problem. That's blowing almost all the way through. That's out on the edge. And if you'll, that says AGC. Look at that, 3 amp. Who put a 3 amp fuse in a spot? And if you look, it says 8 amp. Well, somebody was not smart. We're just going to check the. We'll see if I can set this up without smashing everything. Okay. I'm just going to see if I can get a noise on this thing when I chopstick it here. Nothing. No voltage there. That's clearly blown. So we'll set that aside for right now. And I'm going to test the other one. This is another 8 amp, but only 6 volt, which I think is interesting. The voltages were really different back then. And I don't know how they're going to get kind of fuses like that. And I dropped that. And let me look at it quick. Bent. It looks okay. See if they put they say 8 amp. I want to see if they put an 8 amp in here. Focus. Okay, that focusing isn't really helping much. Here, that might be better. G10. I don't know if they put a good. I can see at the bottom there, like I got a light. You can see like it looks strange. The bottom of this thing. Anyways, not really worried about that per se. You know, we found our blown amp fuse, that is. This is 32 volts as well, which is fine. It isn't, voltage is, amperage is a little bit more the concern. This is the same one that was in the other one, which was only supposed to be 5. I have a couple of 8 amp slow blows, so I might just replace both of these. I can check to see if it makes a noise, I suppose. Let's make sure that see it's got connectivity. Yeah, it works. But I feel like I want to put an 8 amp in there anyways because that's what they say to go. I can't really read it now. There it goes. So that's 8 amp back there. Trust me. Well, I'm going to get some 8 amp fuses and give it a shot. All right, folks, I have found some 8 amp, 250 volt slow blow fuses. 250 volt, it might be like, that seems really high. You can go up in voltage when replacing fuses. You can see that said 50 volt and actually I think it says 6 volt back there. Can I give me a light? Yeah, it says 6 volt and 50 volt. But so you can go higher in voltage, but you don't want to go any higher in amperage. And I think that, trust me, it says 8 back there on amp, which is really strange to have a 6 volt fuse and 8 amp. 6 volt, 8 amp fuse, that's very strange. All right, so, all right, well, I pulled 2 out of here. And we'll see how it goes. It should solve the problem, but hopefully it doesn't like put the fuse in, light it up, you know, turn it on, and then it blows that fuse again right away. That would be concerning because this is a better fuse than I put in that was probably in there. And if it blows this, I have got a lot of back to the drawing board to do. So this is probably gonna solve the problem, don't worry. All right, I'm gonna put this coin hopper back in and then we'll see what happens. All right, coin hopper back in place. These slide in pretty nice and snug. It's kind of nice, the pieces, they come out and make life easier to work on. At least they were smart on that when they did that back in the day. I'm going to close it and see how it goes, and then we'll, if we have bad luck, we'll open back up. So this key, this controls this, so it goes up and down, all the way up. There's also, I have to make sure that touching that switch on the bottom there, because This also will kill everything too if you don't have that turned on. And all right, we're tight. Let's see. Hold on to your butts. Okay, well, that's new. It says winner paid. We don't want to say winner paid, we want to say insert quarter. New is better, I would say. I'm guessing a coin's gonna fall right through because that, I'm not gonna do that right now. I'm not even gonna try a coin because I already know what's gonna happen. So winner paid light is on. And I'm going to try it. Well, I don't have to put a coin, I'm just gonna flick this. Nothing. Pretty much exactly where we were. Except that light's on right now, which is odd. All right, I'm gonna have to go check and see if that fuse is blown again. If it's not, then I'll have to go back to the drawing board just and see what's next I can check. This is still not pulling over yet. It's unfortunate. All right, be back in a bit. All right, folks. Well, I figured out what's causing the fuse to blow. In my investigation period, before I even started taping and starting to document this stuff, I noticed these two cords were just split, and they have the same, I can get the mark, they have the same markings, right? They're brown with a yellow stripe and brown with a yellow stripe. And this has got green with a brown stripe. And I was like, these two are the same color and striping, so they got to go together, right? They just somehow got cut, got severed. It looked like it got just severed. And I was like, I think that should go together because they look the same. And I followed this cord up here all the way down to this interlock switch because that's where it starts. This is a door switch that just kind of goes in when the door closes and it turns something on. I'm not quite sure what yet. But I assumed it just had to be connected, right? Because that maybe been part of my payout problem. Like that it's not paying out. So I thought, well, these two are the same color, right? And even the same, off color with the yellow. And I put them together, fuses were blown. As soon as I disconnected that again, fuses stopped blowing. So I powered and tested that out, and that's fine. And I put a piece of tape on here just so I know that this is the door one and this one was random. And I don't know where this is coming from. So it's like goes down and it goes into here somewhere and it probably plugs in to the reel, I guess. So I was like, so what happened? What should I, what's the problem? So I go over the schematic here. I'm using Galactic Battleground as my schematic indicator here. Let me get something. I've got the reel sitting over here. I'm going to use this little tool to point out some things. So the color indicator here is, if you can focus. Yep. So we got brown, right? Brown is 6, and the yellow striping is 3. So 63. The first number is the body color. Second number is the tracer colors, and then after the dashes indicates the multiple uses. So you'll see 63-1, 2. They've reused colors, and that would probably got me screwed up, right? So I'm looking for 63, or I'm looking for that door switch and trying to figure out where things go wrong. So, all right, so here is the door interlock switch, and it's normally closed because the door will be closed, right? So that's closed, and you can see the color right there, 63-2. So that's right, that's what matched up, right? And it goes up into these 3 coils, total in meter, cash box meter. So those are the meters that keep count of things. So that's on these reels. Like, so right here, there's these 2 meters right here and here. And there's another one, I think there's, this one right here. You can't see it. There's a meter right there. And so I'm like, okay, that, I don't care if that's connected. So like, I'm not caring about that, but that means I probably connected to the wrong thing. That's why I was blowing fuses. And I don't care if this is disconnected. because I don't care about those running. I just want it to work, right? I don't care if the numbers are. So I'm looking around here. I'm looking more towards the odds. So let's see if I can zoom out. So you're like, what's this cluster, right? Well, the most thing you know is the boxes. Like, so these are the reels coming in, you know, or not reels coming in. So they're connecting with wires. All these wires are coming in. It's coming into this box. This is a line unit, which you don't have to worry about, but it's mostly getting connected through this. This is like the main communication line that's going to these reels. So the reels will stop somewhere, and it'll stop on these black dots. And if it lines up, it'll fire these things off, and they'll connect it here, and it'll go through this line unit. And the only way it's going to pay out is if the coin relay is closed and the handle release is closed. What connects those two? Frickin' 63. Small. It's a little small here, but it's a long wire there, and it's a 63.3. If you look at the other one they were stuck on, that was open, it's 63-2 right there, which means they're not the same wire. They look the same color and same everything, but they're actually different wires, and they shouldn't be connected. Dumb Kelly just put them in together, and that's the problem. So that's cut, and it's supposed to go to the coin relay and the handle release switch. So all right, let's go back over here. This is the handle, right? And if you look closer, that's the switch. And lo and behold, there is nothing connected right there. That one right there it's not connected at all. It's nothing there. So that is this wire is probably connected there. So what probably happened, I'm assuming I'm right, if I've read the schematic right, is this was, can I focus a little bit? This was connected to this, and the reel came in and just pulled it off. And I might have even done that, or it might have been done by somebody else, who knows? So what I'm gonna do is, I don't know, I think the green one is, I have no idea, I have to look that one up. That one might, if it doesn't work, I'll have to look up that color next to what's down there. I'm gonna tape these to the wall so they stay there. I'm gonna solder this in and clean it up to that switch. And hopefully we get our payout working. I already know that the power works fine. We're not blowing fuses, so this is the kind of the last step. And put the reels in, we'll see. I'll be back after I get that together. All right, I've got it all soldered on there. You can see it right on the switch. We got the white cord holder there in the back, a little wrap around the cords there, or whatever it is, to keep them nice and snug. Zip tie, that's what it is, zip tie. Yeah, losing my words. And I got it left in there to kind of tug it into the wire so it kind of gets holed up a little bit. You can see that peg there on the left. That could have easily caught it from the reels sliding in and out and could have ripped it. So if I slide this in and out, you can see it goes right close to that orangish wire there, and could easily have caught it. So we're gonna hope that fixed our problem with the payouts. So I'm gonna get this in. I'm gonna, there it is, nice and snug. You gotta give it a little bit of extra force so that it can close, and make sure that it also is touching all the contacts in the back there, because we don't want that. So, all right, I'm going to get it set up, and hopefully this works, and I'll be right back. All right, I got plugged in. Lights are on as I expected. I'm going to put a coin in. Everything lit up. That's good. So that was after the power starts. So insert coin came on. This indicates how many coins we used. And this just shows what the jackpot could be if you were brave enough. So I got wires dangling here. Insert coin came up. That's good. I'm also going to grab some coins. Winner paid light's not on. This will come on when we get, which is a coin accepted. That's great. Winner light's on. We might be in business. We're gonna have to keep playing. I'm gonna I wanna make sure this goes across as we put coins in. Okay, that's 2, perfect. 3, 4. Now the fifth one, this insert coin should go away because you're at max and coin acceptor still stay lit. And it didn't do it. Well, that's fun. Fifth time's a charm, so 8 a coin. And now it's flickering, that's intentional to get a little flasher, like we're at max. All right, we haven't gotten a winner yet, but insert coin. All right, I'm just gonna play one coin at a time now. Just try to get a winner to see if we get a payout. Oh, oh, we had any bar, that was $1. Should that be 20? That should be 20 coins. Winner paid, look at that. Awesome. That should be $1. So yeah, 5 times $20. So there should be 20 coins here, which I think there are. 2, 4, 6, 8, 10, 12, 14. Yeah, there's 20 coins here. Wow, it worked. It freaking works. Bar, bar, bar. And I wonder if no, see this winner paid light goes out if I start it again. Coin accepted. That didn't give me my second one. Let's try it one more time. There we go, we're at 2. Winner paid light went out. Yes. Almost got another coin thing. Awesome. Might have to tweak the thing to make sure we get accurate coin ups here, but other than that, we're in business. Looking good. That's missing another bar there, but that would have been nice. I want to get one more winner to see if I was lucky. Going crazy, betting 2 coins at a time. Nothing. I really like this that it's a simple one. Dang, it didn't work again. I really like this one that it's a simple one where it there's not many different options. It's just one line. It's easy to figure out if you won or lost. Cherry. Sweet. I got paid 4 coins for cherry. Winner paid. We're in business. I'm gonna have to look at the coin thing to make sure they all register at the same time, but we're in business. Successful fix. Hope you enjoyed the show.